Module 2, problem number 12. The shape of the distribution of the time required to get an oil change at a 15-minute oil change facility is unknown. However, records indicate the mean time is 16.7 minutes and the standard deviation is 4.9 minutes. Complete parts A through C. Part A, to compute probabilities regarding the sample mean using the normal model, what size sample would be required? If you go to, I think it's in section 8.1, it talks about the sample size required. Basically, the idea is the more data you have, the more likely it is that your sample mean will be closer to the mean. So you can do, in this case, the sample size needs to be at least 30 or greater than or equal to 30. So we can say A is the answer. Excellent. Part B, what is the probability that a random sample of n equals 45 oil changes results in a sample mean time less than 15 minutes? To find this, we need to first find the mean of the sample mean. Remember, that's that mu sub x bar. And then we need to find the standard deviation of the sample mean. That's that sigma sub x bar. So let's take a look right here. So we have mu equals 16.7, sigma equals 4.9. We know that the mean of the sample mean is the same as the mean of the population. The standard deviation of the sample mean is the standard deviation of the population divided by the square root of n. So that's 4.9. Again, that's the sigma from the population, and n is the number of observations in that random sample. So once I click that into the calculator, we have 0.730449. So now we have the things that we need to convert our x value from the problem to our z value to use the standard normal distribution table. So remember, from the problem right here, we're looking at what's the probability that this will be less than 15 minutes. So that means our x is 15. We need to convert that to a z value. So we know that z equals x minus the mean over the standard deviation. Again, we're going to use those ones that we just calculated, not the ones from the population. The sample mean, the mean of the sample mean and the standard deviation. So we have 15 minus 16.7. Remember that 16.7 is from the problem. And that over the standard deviation, 0.730. Once we type that into the calculator, I get negative 2.33. Now here we only need to round it to 2 decimal places because when you look at the standard normal distribution table, it only goes to 2 decimal places. So you need to round it there. So let's take a look at that table. So let's go. So we have negative 2.33. So here we have negative 2.3. Then we need to go over to 0.033. And so that gives us negative 2.33. If you have any questions about that, let me know. It was in the lesson this week, and I know it's in the interactive text, so let me know if you have any questions about that. So then we know that the probability of that happening is 0.00990. I just want to point out again, the original standard normal distribution table in the appendix of the text only goes to 4 decimal places. So if you're working on this, you really just need to round it to 4 decimal places. Let's go back and plug our answer in. So we have 0.0099. Let's check that. Well done. All right, now this part C, this is the one that I really wanted to show you all how to do. There's something, I don't know what the real, I've always called it a reverse table lookup. That's how I think it's the best way to think of it. It's when you are looking for a specific probability and trying to find out which value that would correspond to. This is something that we cover a little bit more in depth in Module 3. It's a new part of the problem in this problem from last session. So I really wanted to make sure to cover it and show you how to do it because I didn't want you all to be caught off guard. So suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. On a typical Saturday, the oil change facility will perform 45 oil changes between 10 and 12 p.m. 10 a.m. and 12 p.m. Sorry. Treating this as a random sample, there would be a 10% chance of the mean oil change time being at or below what value? There's a little typo. It should be framed as a question. But anyway, this will be the goal established by the manager. So there is a 10% chance of being at or below a mean oil change time of what minutes? So the first thing I want to point out, we are looking for where there's a 10% chance of something happening. That's the same thing as it's saying the probability of 0.10. Remember, you just divide by 100. So let's go to our standard normal distribution table. Again, this is the one that was in the PDF that I put in the announcement this week. So we're going to go look for the closest value to 0.10. So I'm looking here, we have 0.03, that's at 3%, 5%, oh, we're getting closer. So here's 8%. Here, now here's 10.027. That's the closest value I see to 10%. This one's a little farther away, this one's a little farther away. So that would correspond to the value negative 1.2. Let's go up to see, it should be 0.8, but just to check, 8. So that means that a z-value of negative 1.28 has a probability of 10% of happening. Anything less than that. I'm sorry, let me rephrase that. Z has a probability of 10% of being less than or equal to negative 1.28. So now what do we do with that? That just gives us a z-value. That does not give us the number of minutes. That's what we need to convert it back to the x value. So it's kind of the same way we converted our x to the z. We just need to solve it back the other way. So let's take a look. So now we have, so remember we had z equals x minus the mean divided by sigma. So now let's take that and solve for x. So basically multiply sigma over here and then add the mean in. We're going to get x equals z times sigma plus the mean, which equals negative 1.28. That's the number that we just found in the table, multiplied by the sigma from up above. Now I want to point out here too, the reason we can use these same numbers that we use from part B is because we have the same sample size. We have that 45 cars in that time window, so we can use it. If we did not, we would have to recalculate some of these numbers. So just that's why we can use that. And then now we need to add in our sample mean. So we have plus 0.16.7. So once I plug those in the calculator, I get 15.765. So let's go plug that back in to our problem. We need to round to decimal places. What did I say? 15.8 once we round. So 15.8 minutes. Check answer. Well done. So again, this is kind of a reverse table lookup. So, and not only that, then you have to go back and solve for x after you find that z value. I hope this is clear how to do that part. If you're still not clear or you have any questions about any of this, let me know, and I'm here to help. All right. I hope you guys have a great day, and I hope Module 2 is going well.